In question 8, we're looking for how many carbon peaks we would expect to see in each of these molecules. And so what becomes most important for us to look at is where do we find symmetry in each of these molecules. And so I'm going to start with what ends up being the easiest one of these. And that's this fourth compound here. Why do I say that's the easiest one? Well, for this compound, it's just one large carbon ring. There's no substituents on the ring. Therefore, every single carbon in this molecule is equivalent. And so we would see just a single carbon peak in its spectrum. Now, if we continue along the bottom row, we have a molecule that's almost symmetric. But it has a methoxy at one end and an ethoxy at the other end. So therefore we don't have symmetry going in that direction. The only symmetry that we have is going this way through the aromatic ring. Otherwise, the group at the top versus the group at the bottom are going to be different. And so we can see our different carbons as we draw them in here. So again, the two sides of the aromatic ring are equivalent, but nothing else has any equivalency in this molecule. And so we get a total of 7 unique carbons in this compound. Continuing to the right, we have a clear line of symmetry in this molecule, and so we're going to end up with 4 different carbons here. Now we can go to our top row, and there's not a lot of symmetry in this molecule, but it does exist in 2 places. One place is within the aromatic ring. The other place is the 2 methyl groups at the end. Other than that, everything in this molecule is unique. For a total of 10 unique carbons. This is very similar to the next molecule, where again the only equivalency we have are these 2 methyls. Our last molecule is probably the most difficult. It's the bicyclic ring system. But there's actually several ways we can see symmetry. We can see symmetry this way through the molecule, as well as this way. So that greatly simplifies our number of carbons. This one here up at the top is unique. The 2 bridgehead carbons are equivalent, and the other 4 carbons are all equivalent as well.